Ever wondered how cities manage parking rules, zoning laws, or food truck regulations? Or how legal systems handle complex, ever-changing rules that depend on time, location, or exceptions? Today, we're exploring a groundbreaking framework called OLG++, a tool that's transforming how we model legal and regulatory rules using structured machine-readable graphs. Let's dive in. At its core, OLG++ is an evolution of obligation logic graphs, OLG, a system that represents legal rules as interconnected nodes and edges. Think of it as a digital map of obligations, permissions, and exceptions. But traditional OLG had limitations, especially when dealing with spatial constraints, time-sensitive conditions, or multi-party responsibilities. That's where OLG++ steps in, adding powerful new features to tackle these challenges. Let's start with the basics. Imagine a simple rule: a food truck can only park on public streets for 60 minutes. How would a computer understand this? Traditional systems might struggle with nuances like time limits, locations, or exceptions. OLG++ solves this by expanding the graph's vocabulary. For example, spatial awareness. Nodes can represent locations like near schools or within 500 feet of a park. Time-based logic. Rules can specify when they apply, such as daylight hours only. Complex exceptions. Conditions like unless there's an emergency are explicitly modeled. Group obligations. Rules involving multiple parties like both the food truck operator and the kitchen manager must sign a log are captured as interconnected nodes. The key insight: legal rules aren't just simple if-then statements. They're layered with exceptions, hierarchies, and contextual clues. OLG++ models this complexity by introducing richer node types. For instance, a party group node represents shared responsibilities, like a business collective. A location predicate node specifies where a rule applies, such as within 500 feet of a school. A defeasibility node handles exceptions, like unless it's a permitted event. Let's break it down with a real-world scenario. Suppose a city says, food trucks can only operate in residential zones if they're 500 feet from schools and have community approval. The original OLG might struggle to capture both conditions. OLG++. It maps each part. A logical group node combines 500 feet from schools and community approval. A defeasibility node handles exceptions, like unless it's a permitted event. Spatial and temporal constraints are explicitly tied to the rule, making it easier to query later. This isn't just about better organization, it's about smarter legal systems. With OLG++, computers can answer questions like, what restrictions apply to food trucks near schools? Or, can a food truck operate during a public event? By traversing the graph. It's like giving machines the ability to read and reason about laws, not just store them. But how does this tie into broader legal tech? Let's connect the dots. OLG++ builds on frameworks like LegalRuleML, a universal language for legal rules. Think of it as translating legal jargon into a code that machines can process. It uses Deontic logic, a branch of philosophy and computer science that models obligations, permissions, and prohibitions. For example, you must pay taxes, or you may drive 65 mph. Then there's knowledge graphs, which link legal concepts like cases, statutes, and contracts. These graphs reveal hidden patterns, making it easier to search and analyze laws. Tools like Cypher, used in graph databases, let researchers ask complex questions, like which laws apply to food truck permits in this city. But OLG++ isn't just theoretical. It's being applied to real-world problems. Imagine a city council using it to model zoning laws, or a business using it to ensure compliance with health codes. The result: faster, more transparent legal processes and fewer errors. So what's next? As AI and legal tech evolve, frameworks like OLG++ will become even more critical. They're not just about automating rules, they're about making the law more accessible, predictable, and fair. Whether it's smart contracts, automated compliance checks, or AI-driven legal advice, the future of law is being built in code. Thanks for watching. If you want to explore this deeper, check the links below for papers on OLG++, LegalRuleML, and Deontic logic. And if you're curious about how this all works in practice, let me know. Next time, we'll walk through a full OLG++ model step by step. Stay curious and keep learning.